Hey everyone. So last time we spoke, I was trying to get the object interactions working, which I've made pretty good progress on, which I'd like to show you today. But before we do that, I just wanted to give you a quick run through of the server. I don't think I've shown this before. So we'll just start from the first connection all the way through to the main loop where we're watching for changes to entities and receiving packets and sending packets out. So the first place we should start would be the main method here, where we set up the database connection, prepare the opcodes, the map manager, set up the world, the timers. But the main piece here is the world loop, which is set to run at most every 50 milliseconds. So we need to make sure the world updates run within that time. The connection is handled down here. So this is just a pretty standard way to open up a TCP connection in Go, listing on port 5000. The client connects. We make a new socket and we open that up. And this is where basically all the data handling happens coming from the client. So we read the data that comes from the client, split it out, and push it into a packet queue. And then we read off that packet queue and handle the command that's been sent. So here you can see straight away, before we even get into the main server, we're handling ping and authentication. So before the client can start requesting data from the server, like character lists and all that kind of stuff, it needs to send an authentication packet, which at the moment is just a very basic string token. But that'd need to be updated if this is going to get anywhere near public release. So once it's authenticated, the packets then start getting pushed into this queue, and the queue is handled in that main world update. So you can see here we're updating the existing sessions. So if we go in here, you can see we're reading off that queue that we pushed the packets to. We're calling the handler that's associated with that packet. And we're handling a few cleanup cases down the bottom here. Now, the next thing that we're doing is we're updating the maps. And so what we do for that is we go through each player that's currently loaded on each map, and we call update on those. There's nothing in there at the moment. That's going to come later. We process relocations. So if we received a packet when we were processing those packets before that said a player had moved, they would be flagged as having moved, and this process relocations function would find those players, update their position, and broadcast that to players that are nearby or entities that are nearby that player. So if we jump into this relocations method, you can see here that we're creating this relocation notifier. So these notifiers are, there's a few types of them, and I won't get into all of them now, but essentially they crawl through the map and they find entities and players and creatures based on different parameters. So this one is going to find players that have recently moved or had their visibility changed, like perhaps they've gone invisible or just moved a little bit, and they need to update players in nearby. One of the easiest ones to understand would be this one that is sent when a player logs in. So when a player logs in, you want to show them everything nearby. So there's nothing to update. There's nothing to destroy. It's only create everything. So this notifier, the visibility notifier, pretty much just goes down and gets all the entities that are nearby the player. So I'll show you how that works. It's actually pretty cool. It uses something called spatial hashing. So you can see we're passing in the player's X and, well, Z, but position, which is basically just the 2D plane, and a maximum view distance, and then the notifier. So if we jump in here, you can see something interesting happening. We're calculating an area based on the player's position plus a radius, and it's not a circle like you might assume. It's actually more of a grid like this. So there's another one down here. So this is more like what's happening. So we've got the exact location of the player, but we're not going to use that, because if we use the exact location, we'd have to go and check the distance to every single entity on the whole server to find out who's nearby. But if we do spatial hashing, we can say, okay, the player is within this particular square. We get the cell area, which is essentially just this gray box, and we start from the bottom corner here, and we check every cell on the way up. And so the way this is stored in the database, in the server, is pretty much like this. So all these entities map to these buckets. So when you visit these buckets, you'll know who's in what bucket, and it's a very, very efficient way to find nearby entities, which is exactly what we're doing here. So just like the diagram, starting at the bottom left, working our way up to the top right, visiting all the cells. As we're visiting, we're ensuring that the cell's created, which is important because if we just visit an empty cell, there might be entities there that are not loaded yet. So we need to load the cell as we're visiting it. And so when the cell is created, we load the objects that would appear there, and then that allows the notifier to find game objects, creatures that would usually occupy that cell. Yeah, so once we get down here, you can see visit players, visit creatures, which is basically populating the notifier. So if you look in here, it's got a player and creature maps. So as it visits each cell, it pushes into those. Then when we go into this notifier center self, this is pretty much where I've been spending a lot of time. So for each creature, we update the visibility for the player. So we go, can the player see this creature? Or for a player, can this player see the player? So, say it's an enemy that's gone invisible. You shouldn't be able to see them, but maybe a friendly player can. So there's all these rules that we can factor in here. So we'll just jump into one of these and have a look. So you can see here, if the player already has this object loaded, but now it can't see it. So it could have seen it, but now it can't see it. We send or add to the packet that we're about to send a destroy command. If it doesn't have it at the client, but it can see it, we send a create. We build a create packet to send. It gets a little bit complicated here because different objects, different entities are built in different ways. So when I click through on this, it's not going to send me to any one of them because it's implemented differently on each one. So we'll just do the player. So here we have this create update block implemented for the player. There's some to-dos here, like initialize the player's equipment and all sorts of stuff like that. But if we jump into the create update block that's on the base object, we can see that we're adding the update type create, the object's ID, the type of the object, And this build values create is another one of those ones that's implemented per object as well. So if we click on here, we can see it's implemented for a few other things, but we'll just do the one for the player. So a player is extended from an object. So everything is an object, essentially. But we've added on a unit and then additional player data. So when we run this, we're pushing all the object data into the packet. We run this one, we're pushing all the unit data into the packet. We run this, we're pushing all the player data into the packet. So just an example, the unit data, we got health, max health, level. I mean, this is just a very small subset just for playing around with. But yeah, so once we've built all this, we eventually end up back here with this send to self. So once we've collected all the information about who's getting destroyed, who's getting created, what information do we need to send for those, every object has told us what it needs, what it wants to show to the client. We bundle it up into a packet and send it to the client. So because this packet is a very well-defined structure, the client just reads it in, makes or destroys entities as required, and it's actually a very it's quite an efficient and good and nice process. Now, updating entities. So we've created all of them, but some of them are going to be moving out of range. Some of them are going to be going invisible or logging off or whatever's happening. Updating is where I'm up to, and it's a little bit more complicated.